right, so you were supposed to kind of read through the notes. I asked you to graph. The equation and then find the domain and range. And then if you could change it into interval notation, that's the only thing that was new. So up here was a summary of how to write interval notations. Like the parentheses would be used, we would use those if it was greater than or less than, but like not equal to the number. And if it was greater than, less than, and equal to, then you would use a bracket in its place. And then infinity goes on forever, it never stops. So it's never equal to infinity, so that would be parentheses for any infinities. And then I had a bunch of examples of the domain in set notation and how you would write the domain in interval notation. And there's no difference between writing range or domain, it's just, I just went with that. Y's would work the same way. There's one up here that I didn't give you, and I think it's kind of important that we do have it as an example, especially for those of us that have never done interval notation before. And that is, what if x is all real numbers? Why is this not right? What if we had...
Lockdown in place is lifted. Thank you for cooperation.
Good job.
We monitor the situation, and there's a few things we need to get corrected up, but we will let people know that individually. Appreciate your time. Have a fabulous rest of your day. As always, go backwards.
Okay, so if the answer is all real numbers, and we need to write that in interval notation says we're going to start at what and go all the way through what? Yeah. Negative infinity and positive. And infinities get parentheses, not brackets. Oh yeah. So I'm wearing a poofy sleeve, and my sleeve likes to make marks. I'll be doing a lot of undos today. I don't think about that when I get dressed. So we're just going to practice interval notation on top of graphs today. So if that's brand new to you, you'll get it. It's pretty easy. So A, you had to graph, and you made a table. The table of values should be centered around x being negative 5. Because that x at negative 5 is the passenger. So you want to pick values on either side. I picked numbers like negative 6 to plug in, negative 4, because those are going to give me nice, easy numbers. And then you could pick more. You probably did pick more just so you have an idea of what the branches look like. So we should get that our domain for the x's is everything except for negative 5. So then we're going to write that into interval notation. We want to say it goes all the way to the left starting at negative infinity. And it's every single x all the way until you get to negative 5. So at negative 5, there's a break in the graph. So there's one interval, there's one graph, or one piece of graph that goes from negative infinity to negative 5. And then we're going to put a union symbol, which says, all right, there's another piece of this graph. It's all part of the same graph. It's going to start at 5, and then it's going to be greater than negative 5, and then it's going to be greater than all the way to positive infinity. So since that has two pieces to the graph, it has two parts to the domain. The range is similar. It's everything except for 0. So we're going to go all the way down to negative infinity. And there's one piece of the graph up and down. There's one piece of the graph that goes to 0. And then the other piece of the graph starts at 0, goes all the way up to infinity. We do write these in order from like smallest to greatest. So you can't switch around the pieces. You can go from left to right or from down to up. And then example B, we need to graph x, square root of x minus 4. So I went ahead and graphed that, made a table, graphed it. And then our domain would be everything that's greater than or equal to 4. So we're talking about the x's. We talk about the smallest x. Talk about to the left, starts at 4. And is it equal to? Yeah. So you write that as a bracket. because it is equal to 4, and then it goes all the way up to positive infinity. So since positive infinity is the biggest number, that's why it's written on the right. Smallest number's on the left. And then the range, similar. It's going to start at 0. It's going to go all the way up to positive infinity. So we'll have a bracket at 0 going to positive infinity. Now, if you have questions while I'm doing this, like why did you write that as a bracket, or how did you get 4, stuff like that, please ask, because I can't read your mind. I don't want to find out on the quiz you didn't understand it. Yeah.
Why is there a bracket?
Why is there a bracket? Because we use a bracket when the end number works in the equation. So 4 is a value. I can do square root of 4 minus 4 square root of 0. I can get a value for that. Where on this one, what happened if I put in negative 5? It's undefined. So this one did not equal negative 5, but it went all the way up to it. So that's it's just a symbolism that means parenthesis is not equal, bracket it is equal to the endpoint. Thank you for asking. Okay, and then the third one, we had negative x squared plus 1. The domain is all real numbers. So we say how far to the left and how far to the right does it go? Goes to negative infinity through positive infinity. Why is it a parenthesis and not a bracket? Is infinity a value I can go to and stop? No. It goes on forever, so we can't ever equal infinity. Range. You have to think about this. This one's the tricky one. You have to think about this like, what's the lowest number? The lowest number that it goes through. It goes to negative infinity, so that's its starting point, lowest number. And then it goes all the way up to 1. Do I use a bracket or do I use a parenthesis? Bracket, because it is equal. It works. Exactly. So that's interval notation. So today we're going to do section 1.6, which I'll pass out your notes in 15 seconds from here. We're going to do 1.6 day 1. We're going to learn, review, relearn transformations of functions. And we're going to use domain and range to practice in interval notation. So I have, yeah, you can put those notes away. I have notes 1.6 to hand to you. That's what she. I think transformations are so easy. So I hope that if you didn't remember them from last year, maybe your teacher didn't do a lot of transformations, I hope that you see how easy the transformations are after today's lesson. Get excited about them, they're so easy. So we're not just doing transformations like for one lesson either. We're going to apply transformations to lessons in the future, like when we graph logarithms, when we graph trigonometric functions like sine, cosecant, and cotangent. We graph all those, we're going to use this stuff as well. So I have a bunch of examples and explanations about transformations. There's two main kinds of transformations. There's horizontal transformations, and there's vertical transformations. There's also rotational ones, but we don't do that. None. So I've kind of given you a few examples of horizontal, and this is how I'm going to describe it. Horizontal transformations, when you look at the equation, you will know it's horizontal transformation if the transformation is inside of the actual parent function. So inside, that could mean there's parentheses, but sometimes you don't see parentheses, so you have to know that they're understood there. If you think about it being part of the function, it might help the most. So this very first example, I'm just rewriting it, it's bigger, but it's right there. H of x equals x minus 9 squared. And then you think about the parent function, which is f of x equals x squared. So that's our parent function. In section 1.5, that's when we went over parent functions. So if you forget numbers for the parent functions, if you forget their shapes, you can pull out your notes from 1.5 while you're doing your assignment. Looking at this blue one, f of x equals x squared, and then the purple, h of x equals x minus 9 squared, how are they changed? How's the parent changed? That's cool. Okay, so you gave me even more information than I needed. You just say, oh, there's a minus 9 in there, right? That's how they're different. So that means there's a transformation. What you want to do is determine if it's horizontal or vertical. If it's inside of the parent function, this parent function is squaring. Is that 9, that minus 9, part of that square? Is it inside of the function? Yeah. Like the 9 would end up getting squared at some point if you multiplied it out. So that's how I know that it's horizontal. If there was I'm making one up real fast here. If it said x squared minus 9, this would not be horizontal because the minus 9 is on the outside of the square. Like you square the x, then take away 9. So that was vertical. Another thing about horizontal is that when you figure out what the transformation is, it's always opposite of the operation of the function. All horizontals are opposite. So when I see a minus 9 here, horizontally, I'm going to want to do this way, but it's opposite. You got to go this way instead. So what Cole said earlier, or you could read, this would be a translation that goes 9 units to the right, even though it says minus 9. So here's another example, and this one we did not do parent functions for, so that's why I put this one down. So the parent function of this 5 to the x plus 2 is 5 to the x. So it still has that 5 in it. And you can see there's a plus 2. Now this is an exponential function, which you probably covered in some class at some time. Exponential. Is the plus 2 part of the exponent, or is it outside of that? It's part of the exponent. So there's not parentheses to really determine if it's inside or not. But technically, we should know that if it's part of that exponent, we would have to do x plus 2 first, then do 5 to that number. So it is part of that exponent. So this would be horizontal. If it's horizontal, it's opposite operation. So instead of plus 2, horizontally, we would do what? Minus 2, which means go to the left. We're going to translate to the left. And then in this box, I have every single horizontal transformation that we will use. Today, we're not using all of them, so this is a summary, and then tomorrow or Thursday, we're going to finish. Oh, hey, Thursday? I have a bunch of doctor's appointments, so I'm not going to be here on Thursday. So on Wednesday, I'm going to record the notes just like I'm doing right now. I'm going to post them, and I'm going to have a computer card in here. You can also watch it on your phone, and you'll have the assignment. It just won't be me. But it'll be me, too, today. Just not live. Okay? So you're totally expected to do everything that my Wednesday class is going to do. And you have a good spouse. You could get help from her as well. So anyway. But I'm not worried about my second one. Should I be? Okay. Here's all the different kinds of transformations. So if you have a minus some number inside of the function, then it would translate to the right. If it's a plus a number, it would translate to the left. If we have a minus x, like a negative sign, like a multiplying by -1 inside the function, it's called reflection in the y-axis. That is a horizontal reflection. So I'm going to kinesthetically do this with you. Kinesthetically means give me a y-axis. Give me a y-axis. Kinesthetic. Give me a y-axis. So I'm going to reflect something horizontally. Reflecting it horizontally. See how it's going left to right? Do you see how this is going left to right? So that is a reflect in the y-axis. People always get confused. Do you write in the x-axis or do you write in the y-axis? Because it's a horizontal transformation, it's confusing. So if you actually put your axis up, you can see which one it's reflecting in the. Doesn't that sound weird? In the y-axis. That's the correct vocabulary. So we're going to use the correct vocabulary even if it sounds weird. So over the y-axis, you write in the y-axis. And here is, exactly how to write it. And then today we're not doing shrinks or stretches, but tomorrow we will. And the shrinks or stretches, the formula is given here. If you're multiplying by a number inside of the function, it's either a shrink or a stretch. And that will determine if that number you're multiplying by is greater than 1 or between 0 and 1. That will all be in notes tomorrow. Vertical translation transformations would be outside of the function. So my example is that we have absolute value of x take away 7. So my parent function is just absolute value of x. So is that take away 7 inside of the absolute value or outside of the function? Outside of that function. So this would be a vertical translation. And vertical ones are nice because their sign or their operation is exactly the same. Horizontal is opposite, but vertical is exactly the same. So here I've got all the different examples and what their transformation is and what you would do for their transformation. But we're just going to practice that. The tables are there for you if you need them to go back and look at. So the first example, g of x equals x squared minus 3. I'm going to go over this one like it's a super hard one. It's not. So I'm going to go over it like it is so that when we get to the hard ones, you've seen all the steps. All right? It's notes. Always do more in notes than we actually do on our assignment. So the first thing I want to do is figure out what the parent function is. What's my parent function for x squared minus 3? X squared. If I do not remember the original x squared, I forgot to write the f of x. If I do not remember the original x squared parent function points, that would be in your notes from 1 to 5. I, thank goodness, remember because I do this every single year, multiple times. So good for you, I remember. They're just squares of the original numbers. When I graph a parent function, it's not really part of the actual answer. I always do it dashed. It's not really the answer, it's just the original parent function. Now, when you write your transformation, we are going to write it using the mature mathematical vocabulary that we're either learning in class today or have learned in the past. So I know some of you already worked ahead and wrote down 3. That's not enough. You need to write the mature vocabulary that says, how are we going down 3? We are going to translate down 3 units. So that's what I expect to see on your assignments and a quiz or test. The word translate down 3 units. Now, I could just look at this graph and move the entire graph down 3 units. Totally easy, could do that. But if I can't just look at the transformations, maybe we have 4 different transformations going on, what we're going to do is we're going to use this table. So I'm going to use the table, however, I don't think you need the table for this one. But I'm going to use the table, just to get us used to it. So since we are going, excuse me, down 3 units, is that a vertical or a horizontal? Vertical, so on the vertical side, that's my y values. I'm going to write subtract 3 to all my y values, because that's what it's affecting, the vertical. So 6, 1. And then once I've replaced those y's with new y's, I don't need the old y's anymore. So then we graph the original x's and the new y's. And you should have your picture that is transformed, translated, down 3 units. We need to write our domain and range, and in this assignment, we're writing our domain and range in interval notation. So you're going to think to the left, to the right. And you can think about set notation first. Like for the domain, it's all real numbers. So how do we write all real numbers? We say it goes from negative infinity to positive infinity. All real numbers. Range, is that all real numbers? Does it go all the way to the down, all the way to the up? How far down does it go? Negative 3? Does it equal negative 3? Yes. So we write bracket negative 3 all the way up to infinity. Okay. Next. You guys are going to raise your hand if you have a question about how'd you get that? Or if I get it too fast. I'm recording this video right now. You could go back and pull it up on YouTube via Canvas. I go to Canvas and then click the link from there. All right, next. What is our parent function for this one? F of x equals x squared. Then we look at x plus 5 squared. Is that plus 5 part of the squared function? Like if I were to multiply it out, root 5 gets squared. Look, so that's inside of the function. That is a horizontal transformation. So the translation for this one is going to be translate 5 units, and then anything that's horizontal is opposite. So instead of plus 5, we think minus 5, so we say left. So if I needed my table, which again, I don't need my table for this one. I just need to know where the parent function is and move it left 5 units. But if I needed my table, then since it's horizontal, we do it to the left side, to the x side, and we subtract 5. What's nice about the x column is that it's like in order. So when you subtract 5, it's still in order. It just starts with different numbers, so I do it really fast. Domain would be all real numbers, so we go from negative infinity to positive infinity. Range starts at 0, goes all the way up to infinity. All right, third one. Now we have multiple transformations to worry about. So what's our parent function? x squared still, so it's still those same numbers I've just used. All right, we're going to write our translations, or transformations. Anything that is being done to the original function is going to be a transformation. So we have my original function, pf, as just x squared. So the negative sign out front, the minus 2 inside, and the plus 1 at the end. Those are 3 different transformations. Let's start with negative. This is a negative 1. Is that inside of the squared? Is that negative 1 going to be squared? Or is it outside? So it's vertical. So that negative from the first page is how you get a reflection. Bless you. So we write reflect in the, and then we need to figure out which axis it's reflecting in. So you told me it's vertical, so I need to reflect vertically. And then I stick my axis in there. Which axis is it reflecting in the? Yeah. And then we have that minus 2. Is that being squared or is it outside of the square function? Is it inside? So horizontal. So opposite. We're going to translate 2 units right. And then my next, that plus 1 is also a translation, so I'll just write and. I don't have to write the word translate twice. Translate 1 unit where? Up, because it's a Y, it's a vertical, so verticals keep the same sign. Then if we're using our table, what would we do first in our table? We have multiply by negative 1, we have add 2, and we also have add 1. What comes first by order of operations? Multiplication or addition? Multiplication. So that's the first thing that you'll put in your table. Order will matter. The first thing we're going to put is, since, nope, it's not that side. Since it's a vertical reflection, we'll multiply by negative 1 to all the vertical numbers, the y. And after we multiply by negative 1, then we'll add 1 because it translates up. And then on the x side, we are just adding 2 to make it go to the right. You only graph the outermost x and the outermost y for your final answer. So negative 1, 8, negative 1, negative 8. Zero, negative 30. So you guys are all coming from different Algebra 2 teachers. You know, I don't know how familiar you are with these transformations. Are you leaving? But there is a way that you can kind of help check. You're going to miss kind of the, not hardest, the thing that everybody forgets. So make sure you get on and watch the rest of the video. Okay. Next example. If you go on your graphing calculator and you graph the answer, and if that graph doesn't look like anything like what you graphed, obviously something's wrong. So what would you do? Just erase this and put your graphing calculator answer down? What would you do, Brady? Yeah, figure out your mistake, because that's how you learn. You learn by making mistakes and correcting those mistakes. But the graphing calculator can help you identify those mistakes. And if you are at home and you left your graphing calculator in your locker, do you know what website is really helpful? Desmos. We're going to do some Desmos projects in here. I should give you a sneak peek sometime. But Desmos is so helpful. All right, so our domain and range. Our domain is all real numbers, so we'll write negative infinity, positive infinity. And then our range, what's the lowest y? Negative infinity. And it goes all the way up to 1. And there's a bracket at 1. Okay, the next one is what I was warning him about as he was leaving. So there's a trick on this one. So if you're working ahead, well, eventually you've already made a mistake. You're going to see this in trigonometry a lot as well. We'll do this stuff for trigonometry, which is soonish. When you have a coefficient on the x other than 1, you must factor it out of the translation, out of the binomial. I don't know what I want to say. Out of the function, but still under square root, or whatever function it is. I'm not explaining that very well. You guys remember factoring, right? You did it a little bit last year, a little bit. Okay, so when you have a GCF, this is like GCF factoring. What would this be that I'm taking out? It'll be a -1. So I'm going to rewrite this one as square root negative, or -1, parenthesis, x plus 3. So I took that negative out of that part of the function, but it didn't go out of the square root. It's still part of the square root, because here, if it's under the square root, it's horizontal. It's still got to be horizontal. You just have this extra parenthesis. And when we do that, it's changing the transformation part, the translation part. So if you don't factor it, you're going to get your translation the wrong way. So we factor it. Then we look at our transformations. Our parent function is just square root of x. So if you're writing your table, that would be 0, 0, 0, 1, 1, 4, 2, 9, 3. You're graphing it. Oops, that's not one. There we go. So there's our parent function. Real fast. Again, the parent function stuff's in your notes from 1.5. So if I go too fast on that, it's in your notes. Transformation. So we've got a negative sign, and then we have a +3. Both are horizontal because both are underneath the square root. What's the negative do? To reflect, and you're going to say in the, and again, if you're not sure which axis, then you take your hand and reflect something horizontally and say, what axis is that reflecting over? The y-axis. And then the +3 is translate. 3 units where? Who thinks it's left? Who thinks it's right? Who doesn't know? After you didn't answer. Alright, this would be what? Left. It is opposite. If it's horizontal, it's the opposite operation. Since that says +3, we say -3 or left. So to our table, both are horizontal, so I do both to the x's. What do I do first? Do I multiply by -1 or do I subtract? Multiply by -1 first, then subtract 3. You graph the outermost X and Y. The 12, that's kind of off the graph, but it's kind of close still, so I corrected. The domain. That's going to go all the way to the left to negative infinity. And it's going to go to the right to what number? Negative 3. It is equal to negative 3. Range, it's going to go all the way down to 0. It's going to start at 0 and go all the way up to positive infinity. Yeah. Is there? Oh, no, in the y-axis. In the y-axis. So the next one, you have to figure out what kind of function that was. So we got to figure out the transformations for this next one. We got just 2 more. Let's speed through. The parent function. One over x. It's called reciprocal function, or it's called a rational function. I did them last year, rational functions. So when we look at a transformation, we see a -2 and a -4. The -2, is that part of this fraction? That -2? Part of the fraction. So the -2 is a horizontal. The -4 is not part of the fraction. So that's vertical. So we'll have to translate 2 units. Horizontal is opposite, so 2 units to the right. And 4 units down, because that one's vertical. And then you want to get your original parent function from your notes if you don't remember it. I know that there's an asymptote. There's an asymptote at x equals 0, and there's an asymptote at y equals 0. That's from our parent function. Also, parent function points, we use things like -2, -1, -0.5, 0, half, 1, 2. Then we got -0.5, -1, -2, 0, 2, 1, 1/2. We graphed it, looked like this. I'll move away if I'm blocking. I just have to stand in front of it when I graph it. So that's our parent function. So to that parent function, we are translating 2 units right and 4 units down. So 2 units right, we're going to add 2 to the x's. 4 units down, you're going to subtract 4. You know what? I put a 0 in there. That's not a 0. But I wrote a 0. I wasn't thinking. It's not a 0. Celestial. What should that be? That shouldn't be a 0. What's 1 over 0? I'm going to find out. Oops, there. Okay. So 2 units right, 4 units down. Guess what? With this kind, the asymptotes also move 2 units to the right, 4 units down. So I'm going to just start with the asymptotes because I think it's really easy to graph when you just think about the asymptotes moving. So my asymptotes, 2 units right, 4 units down. And then you can fill out your table and graph those points. I'm speeding a little bit, so when I graph those points, I'll show you where they will be. They're going to be right by your asymptotes, just like the original function was. And then you guys can start the last one. Only get through like transformations of the last one because did you know the wrong one? Only do the transformations of the last one because I want to make sure we're doing it right before you do the whole thing wrong, right? Alright? A good example, especially those of you that are using pen. So start that last one, and I'm going to go over it together. Oh, jeez, we forgot the domain and range. Remember domain and range? This kind skips over a number. So domain is going to skip over 2. So we'll go from negative infinity to 2, then skip over 2, and start at 2 again, go to positive infinity. So it has like 2 pieces, 2 branches. That's why there's 2 pieces in the infinity. And then the range is going to go from negative infinity to negative 4, union, negative 4, positive infinity, because it's skipping over that asymptote. So in that last one, first thing you want to do is just like think about your transformations, but don't do the whole thing yet. Because I want to make sure you're doing it right before you do the whole thing. I want to give everybody a second to start. Mistake in your transformation, so I would continue. Mistake in your transformations. So you just grab them there. All right, so I walked around. Why did I say don't go very far on 5? 5 had something. Who saw it? We had this like 2 examples ago. What do you have to do if there's a coefficient other than 1 on the inside with that x? You have to factor it. It does not come out of the absolute value though. So it's not going to come out and cancel with that one. So it's going to be d of x equals, you're going to have negative, then you're going to have absolute value, negative parenthesis, x minus 1, close parenthesis, absolute value plus 30. So you got to factor that out if there's a number in front of the x other than 1. So that's why I was walking around, just making sure that you had it right before you went on. So our transformations, we're going to have a reflect in the, what's this on the outside, tell me? Which axis? Or is it vertical or horizontal? Outside. Vertical. So if I'm reflecting vertical, which axis? So reflect in the x-axis. And then there's one on the inside also, so reflect on in the y-axis. No way. Alright, so we did mostly everything. Here's your assignment, guys. As you're walking out. Alright. Ta-da. I'm getting to a couple of our minutes. These notes will be posted if you miss something. I don't have time for Friday. I'm coming out like Thursday. Where are you? Right. They walked in for the lunch hour. I've done it. Oh, did you? No. Is that the one that say they were not? Yeah. Okay. Yes, sir. Are you? I think you like Wednesday or Thursday. Bye. Bye. Bye.
Actually, I'll see you tomorrow.
Yeah. Yeah, you leave here. Lunch. I always want to